Alright, I want us to look at this question. It is question on dimension. It says the amplitude of a damped oscillator having mass n varies with the time t according to the expression. This is A, which is the amplitude, equal to A0 exponential minus AT divided by n. The question says we should find the dimension of A. Okay? Now, solution. Before I will start solving this, I want you to look at these principles of dimension. The dimension of an exponential function is said to be dimensionless. For instance, if you have exponential, I have exponential t, or let me say exponential mt, and we are asked to find the dimension of mt. To find the dimension of mt, because this is an exponential function and the power of this is mt, it means that the dimension of mt is what? Dimensionless. It's dimensionless. So this is going to be what? Dimensionless. This is going to be dimensionless. So if you have that exponential t, examiner says find the dimension of t. He says find the dimension of t. The dimension of this t is what? Dimensionless. The reason is because of this exponential function that is attached to this. And whenever something is dimensionless in physics, we can equate it to be equal to 1. For instance, we know that I have something that is called stress, okay, which is what? Force over area, right? This is not dimensionless. But when you have strain is what? Extension all over what? Length. So what makes this thing to be dimensionless is that this one is equal to L and this one is also equal to L. So when you cancel out, you have it to be equal to what? 1. So whenever a physical quantity in physics is said to be dimensionless, we can make it to be equal to what? 1. So if that is the case, that means that for me to solve this problem, this is A is equal to A0 exponential minus A t over n. I want to get a dimension of A. So this means that exponential of this, it means that the whole of this person is what, somebody? Dimensionless, right? So we said minus AT over n is what? Dimensionless. Which means I can equate it to be equal to 1. So if that is the case, we can say that minus, or we know that we don't make use of minus during dimension, right? So we can say AT over n is equal to what? 1. Is equal to what? 1. So if this is equal to 1, what I am going to do now, remember that from the question, they said T is what? Time. M is what? Mass. So, A multiplied by the dimension of T is this, divided by the dimension of N, which is what? Mass, is equal to what? 1. So when you cross multiply this, you will have what? That A multiplied by T is equal to what? N, right? If this is equal to M and I want to get a dimension of A, it means that A is equal to what? MO all over what? T. Which if you want to take this to this side, I can now have my final answer to be equal to what? MO T raised to the power of what? Minus 1. So that the dimension of A is now equal to MO T raised to the power of what? Minus 1. So this is the final answer I have. And if you want to do this check, if you carry this person now as A and substitute here, you are going to have